As we expand our discussion and use of angles and start bringing them into the triangle, we're going to talk about how to complete the steps to prove that the sum of the measure of the interior angles of a triangle is 180 degrees. And then we want to identify and relate the interior and exterior angles of a triangle. And then calculate the measures of interior and exterior angles of a triangle. So we are going to be looking here at some of the words, exterior angle and interior angle. We've already talked about those, but we'll identify them as how they relate to a triangle. Same thing goes for remote interior angle. Supplementary. Supplementary is a term that we should be familiar with, meaning 180 degrees. And your third angle theorem and your exterior angle theorem, we will go into detail with an example later on. But what we do need to know is that when I have a triangle, my triangle, if I have angle 1, angle 2, and angle 3, angle 1 plus angle 2 plus angle 3 is going to equal 180 degrees. And that's just our thing, right? And sometimes people say, well, how am I supposed to remember that? Well, if I look at and I have a square, I know that a square has four right angles. So there is a total of 360 degrees, in a square because of the four right angles. Now, if I were to take and cut that square in half, though, I now have 180 degrees here and 180 degrees here instead of 360 before. So just remember your triangles are going to be angles. The interior angles of your triangle will be equal to 180 degrees. And let's see, as we move forward here, we're going to talk about the triangle angle sum theorem. And what that is going to tell me, again, that the sum is going to be 180 degrees. So now if I look at this triangle that I've drawn, and looking here, I got triangle GFH, right? Triangle GFH. And if the interior angles are all equal to 180 degrees, well, we've already identified angle F and angle H as 53 and 45. So I'm going to have 180 degrees minus, let's do this algebraically, okay? So I have a triangle GFH, and angle G is going to be equal to 180 degrees minus angle F and minus angle H. So if I look at this, and I can also write that as it's going to be minus angle F plus angle H. So if angle G is equal to 180 degrees minus, well, angle F and angle H are going to be 53 plus 45, and then angle G is going to be 180 minus 98, which is going to be equal to not 72, but 82. So my angle G over here is going to be 82 degrees. Or what I was going to do real quick before I got started was going to be 180 minus 53, which was going to be 127. And that was a minus 45, right? And I was going to have 82 degrees. So sure enough, 82 degrees. Well, if I just use some of the information that we've already learned, I should be able to tell you what this angle right here is. Because if you're looking at that, we have this angle plus this angle are going to be a linear pair. So that means that together they are going to be equal to 180. So that means that that question mark there should be 180 minus 82, which is going to render, that is going to give me 98 degrees right here. So that linear pair. Now, if you look at that relation, sure enough, this angle right here is 98 degrees. Well, these two angles added up together were 90 degrees. And that's going to actually be one of our theorems, I believe, that we're going to be working with here in a moment. But before we do, let's go ahead and do one more example. All right, so looking at this example here, I have triangle, and I guess just so we get in the habit of naming it, I have triangle RTS, and I want to know what is K going to be equal to? So I'm going to find K. And you may say, hey, how do I find K? Well, I should remember that these two angles right here are going to be a linear pair because they are supplementary. This plus this is going to give me S. So I can go ahead and solve that with a simple equation of 5K minus 3 plus 9 plus K is going to be equal to 880 degrees. So go ahead and combining like terms. I'm going to combine my K's, and that is going to give me 6K. Go ahead and combine my numbers, and that is going to give me plus 6 is going to be equal to 180. Minus 6, so I have 174, 6K divided by 6, and K then is going to be equal to not 30, but 29. So if K is equal to 29, I found it. Boom. K equals 29. However, now if we want to go ahead and figure out some angles, what is this angle going to be equal to? And we're just going to substitute in K. So I'm going to have 9 plus 29 degrees is going to be equal to 38. Okay. And then this one right here, this one is going to be equal 5K minus 3. So I'm going to have 5 times, I said K and I wrote X, but there you go. 29 minus 3 is going to be equal to 145 minus 3, or 142. And sure enough, if you look at it, 142 and 38 is going to give me that 180 degrees, which would be my linear pair. Okay, so that third angle theorem, as we continue talking about this stuff. Third angle means, guess what? If I've got two angles, and this angle equals this angle, and this angle equals this angle, well, guess what? That third angle also needs to equal. So by virtue of this angle is going to be the same as that angle. So if two angles are congruent, the third one is also congruent. So again, for that third angle theorem, if two angles of one triangle are congruent to two angles of another triangle, then the third angle of those triangles are also going to be congruent. And now we're going to talk about some exterior angles. And the exterior angle, which we did actually discover a few minutes ago, where we said, hey, it looked like this angle that was right here was the same sum as these two angles right here. And what happens is that's actually going to be the case. So it's going to be one of those, it's going to be a theorem, but it's a property. So the triangle will consist of 3 interior angles as well as exterior angles. Because if you look at here, I have 1, 2, 3 interior angles, but technically if I were to extend those sides out into rays, I would have this is an exterior angle, this is an exterior angle, this would have been exterior angle. And then what we can talk about is my exterior angles are created by extending only one side of that triangle, which is what I've done, and they are supplementary to those interior angles. So I should be able to look at this and say, guess what? If this angle is 115, this angle right here should be 180 minus 115, which is going to give me 65 degrees, just by virtue of it being a linear pair. Now, we also talked about the sum of a triangle is going to be 180 degrees. neither here nor there, but I do know that this is going to be equal to, my exterior angle is going to be equal to my two remote interior angles. In these remote interior angles, each of the two non-adjacent interior angles corresponding to each exterior angle of the triangle. So we're going to be able to use those because we know that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. But we also know that angle 4 is equal to angle 1 plus angle 3. Or if I pause for a second, I can turn around and say, well, do some substitution here. I know that if angle 4 plus angle 2 is going to be equal to 180 degrees, we can do the substitution right here where I have angle 2. If 1, 2, 3 equal 180 degrees and 4 and 2 equal 180 degrees, then angle 1 plus angle 3 is going to be equal to angle 4. And looking here, angle 1 plus angle 3 is going to be equal to angle 4. So when I write the equation to figure out what the heck k is and what the heck those angles are going to be, I should be able to say 4k plus 5 degrees plus 6k plus 10 degrees is going to be equal to 115 degrees. So I can go ahead and combine like terms, and I get 10k plus 15 degrees equals 115 degrees. So I'm going to go ahead and subtract that. That's going to be 100 degrees. And 10k, divide both sides by the coefficient. K is going to be equal to 10. So when I plug 10 in, I can go ahead and say, well, angle 1 is equal to 4k plus 5. So that is 4 times 10 plus 5, which is 45. So that is 45 degrees. And do the same thing here with angle 3. Angle 3 is going to be equal to 6k plus 10, and that is going to be 6 times 10 plus 10, which is going to be 70. So it looks like I am going to have 70 degrees plus 65 degrees plus 45 degrees. So, yep, 45 degrees, 70 degrees, 65 degrees. All are going to equal 180. And if you do the addition, you'll see here that my two remote interior angles equal 115 together, and then my exterior angle there equals 115. So sure enough, there's a relationship that my exterior angle equals the two remote interior angles. So we'll be able to use that in the future. So the exterior angle theorem, which we just covered, and we should be able to take this example and do some fill in the blank. I know that this angle is going to be 180 minus what is present, so I'm going to have 180 minus 98, which is going to be, as we said before, 82 degrees. 82 degrees, so that means this angle right here is going to be equal to 98 degrees, again showing that the exterior angle is equal to the two remote interior angles. And then just going ahead and solving another example here where I have this exterior angle is going to be equal to the two remote interior angles, or non-adjacent. So when I go ahead and work that out, I'm going to have 4n plus 6 is going to be equal to 2n plus 60. Do some inverse operations here. And that's going to be 4n. It's going to be equal to 2n plus 54. Go ahead and subtract 2n from both sides. And I'm going to have 2n is equal to 54, or divide by 2, n is going to be equal to 27. So when I plug it back in, this should be 27 times 2, which is going to be 54 degrees. And this would be 4 times 27 plus 6. And you're going to get 80, 90, 108, 104, 114. 114 degrees, and sure enough over here, when I have 54 plus 60, is going to be 114 degrees. So there you go. We're using these angle relationships to prove and justify and find these solutions. And then finally, calculating angles. This is just a quick example that you can work around, and we can actually find every angle measurement here, understanding that this is not drawn to scale. Okay, most drawings will not be drawn to scale, and they will tell you so. Please do not make the assumptions that it's a 90-degree angle. For example, this sort of looks like a 90-degree angle, but it's not. And you would say, well, this doesn't look like 60 degrees. Well, I'm telling you it's 60 degrees because I've labeled it 60 degrees, and it is not drawn to scale. But if I do, as I work my way around, I can say, well, if as a linear pair, if this is 60, then this is going to be 120 degrees. I can tell you that this angle right here is a vertical angle to the original 60 degrees, so this is also going to be 60 degrees. So far, so good. Vertical pair again, this is going to be 120 degrees. I appear to have two parallel lines, okay? And it is cut by a transversal. So then my corresponding angle to this is going to be right here. So it looks like angle A should also be 60 degrees. If angle A is 60 degrees, the vertical angle across from it is also 60 degrees. And if you'll notice, that would have been a corresponding angle to this angle, which is also 60 degrees. So far, so good. This right here is 70 degrees, so that means its vertical angle is going to be 70 degrees. And we have this thing right here is going to be they are going to make 180 degrees. So if I have 60 and 70, that's 130. If that makes this then going to be 50 degrees in vertical pairs, this is going to be 50 degrees. As we continue to walk around these triangles, well, if we have 50 here and 60 here, that means the other interior angle has to be the difference of 180. So that is we're going to have 180 minus 50, and minus 60 is going to give me 70 degrees. If this is a linear pair, then C is going to be equal to 110 degrees, because 70 plus 110 is going to give me that 180. That makes this a vertical pair of 110. That makes this a vertical pair of 70 degrees. And I think I just quickly walked around this entire diagram with those few vocabulary words that we have studied and was able to identify all of these angle measures. So just keep in mind that it's revealing, every lesson that we do is revealing new things in vocabulary that if you know them, it becomes very easy. If you do not take the time to learn them, you will struggle and not know what the questions are asking you. So as we continue on with these triangle angle theorems, we wanted to be able to complete the steps to prove the sum of a measure of interior angles equal 180 degrees. And I want to identify and relate the interior and exterior angles of a triangle and calculate the measures of the interior and exterior angles of a triangle. And just a quick takeaway is, the sum of the interior angles of a triangle is 180 degrees. The exterior angle of the adjacent interior angle are supplementary. And then the measures of an exterior angle are equal to the sum of the measures of the remote interior angles, which we also showed you we worked with some examples that gave us just that information. So triangle angle theorem, as you're learning using these vocabulary words over and over again, It's going to become easier as long as you're working with it.